Okay, so good morning, class. So, our first topic for the finals is all about the big data. Now, first, we define big data. So, big data, these are data sets that grow so large that they become awkward to work with using on hand database management tools. Now, the challenges here is capturing, storing, searching, sharing, analyzing, and visualizing data. So, usually, big data used to describe large collections of data that may be unstructured. Now, if we say unstructured, these are raw data and grow so large and quickly that is difficult to manage and regular database or statistics tools. However, there are certain basic tenets of big data that will make it even simpler to answer what is big data. It refers to a massive amount of data that keeps on growing exponentially with time. Also, it is voluminous, that it cannot be processed or analyzed using conventional data processing techniques. And it includes data mining, data storage, data analysis, data sharing, and data visualization. And lastly, the term is an all comprehensive one, including data frameworks, along with the tools and techniques used to process and analyze the data. Now we have types of big data. First is structured. It refers to highly organized information that can be readily and seamlessly stored and accessed from a database by simple search engine algorithms. For instance, the employee table in a company database will be structured as the company details, their job positions, their salaries, etc., will be present in an organized manner. Now, structured is one of the types of big data, and by structured data, we mean that data can be processed, stored, and retrieved in a fixed format. Second is unstructured data. It refers to the data that lacks any specific form or structure whatsoever. Email is an example of unstructured data. Structured and unstructured are two important types of big data. Now, unstructured big data makes it very difficult and time consuming to process and analyze these data. We also have the semi structured, which is the third type of big data. This pertains to the data containing both the formats mentioned above, that is, structured and unstructured data. To be precise, it refers to the data that, although has not been classified under a particular repository or database, yet contains vital information or tags that segregate individual elements within the data. Okay, so we have here the characteristics of big data. Now, back in 2001, Gartner analyst Doug Laney listed the three V's big data, which is the variety, velocity, and volume. So let's discuss the characteristics of a big data. First is variety. This refers to structured, unstructured, and semi structured data that is gathered from multiple sources. While in the past, data could only be collected from spreadsheets and databases, today data comes in an array of forms such as emails, PDFs, photos, videos, audios, SM posts, and so much more. Variety is one of the important characteristics of big data. Next is velocity. Now we are being bombarded with these data at huge speeds all the time, anytime. Velocity essentially refers to the speed at which data is being created in real time in a broader prospect. It comprises the rate of change, linking of incoming datasets at varying speeds and activity bursts. Last is volume. Large amount of data we are getting from many sources as the world becomes more and more instrumented. Now, we already know that big data indicates huge volumes of data that is being generated on a daily basis from various sources like social media platforms, business processes, machines, networks, human interactions, and etc. Such a large amount of data are stored in data warehouses. Okay, for the volume, we have 2.5 quintillion or 2.5 million trillion bytes of data that are created each day, and 90% of the world data was created in the last 2 years alone. It is estimated that in the next decade, data and content will grow by 44 times from 800,000 petabytes in 2009 to 35 zettabytes in 2020 this year. Next is variety. Now, 80% of the world's data is unstructured, and it may be data we've collected before, but they could not be processed. Now, about 80% of the data collected by institutions is unstructured. We may have been collecting these data before but could not process it and would often discard it. The other 20% of structured data is what we would normally process with RDBMS, or the Relational Database Management System, or statistical packages. Okay, now there are um, two types of big data here in velocity. Now we have the data in movement or streams. For example, we have the Twitter, the Facebook comments, stock market data, sensors to predict the weather, or measuring vital signs of a newly born baby. Those are examples of data that is flowing like a stream. Today, using products like the IBM Infosphere streams, you can analyze these data as it flows. Second is data at rest, or the oceans of information. For example, the data that has already streamed, emails, weblogs, etc. An ocean is the perfect analogy representing huge amounts of data, but it's data at rest, and typically it's unstructured. IBM Infosphere Big Sites is used to analyze this data, this type of big data. Now we have here advantages of the big data. First is, one of the biggest advantages of big data is predictive analysis. Big data analytics tools can predict outcomes accurately, allowing businesses and organizations to make better decisions while simultaneously optimizing their operational efficiencies and reducing risk. Second is, by harnessing data from social media platforms using big data analytics tools, Businesses around the world are streamlining their digital marketing strategies to enhance the overall consumer experience. So here, big data provides insights into the customer pain points and allows companies to improve upon their products and services. Third is big data analytics could help companies generate more sales leads, which would naturally mean a boost in revenue. So businesses are using big data analytics tools in order to understand how well their products or services are doing in the market and how the customers are responding to them. Thus, they can able to understand better where to invest their time and money. Fourth is with big data insights, you can always stay a step ahead of your competitors. You can screen the market to know what kind of promotions and offers your rivals are providing. And then you can come up with better offers for your customers. Also, big data insights allows you to learn customer behavior to understand the customer trends and provide a highly personalized experience to them. Okay, now who is using big data? The people who are using big data know better that what is big data. So let's look at some such industries. First is healthcare. Big data has already started to create a huge difference in the healthcare sector. With the help of predictive analytics, medical professionals and HCPs are now able to provide personalized healthcare services to individual patients. Apart from that, fitness wearables, telemedicine, remote monitoring, all powered by big data and AI or the artificial intelligence that are helping change lives for the better. Next is academia. Big data is also helping enhance education today. Education is no more limited to the physical bounds of the classroom. There are numerous online educational courses to learn from. Now, academic institutions are investing in digital courses powered by big data technologies to aid the all around development of budding learners. Third is banking. The banking sector relies on big data for fraud detection. Big data tools can efficiently detect fraudulent acts in real time, such as misuse of credit or debit cards, archival of inspection tracks, faulty alteration in customer statistics, and etc. Fourth is manufacturing. In the manufacturing sector, big data helps create a transparent infrastructure, thereby predicting uncertainties and incompetencies that can affect the business adversely. According to TCS Global Trend Study, the most significant benefit of big data in manufacturing is improving the supply strategies and product quality. Fifth is the information technology, which is one of the largest users of big data. IT companies around the world are using big data to optimize their functioning, enhance employee productivity, and minimize risk and business operations. So, by combining big data technologies with machine learning and artificial intelligence, the information technology sector is continually powering innovation to find solutions even for the most complex of problems. Number six is retail. They've started to leverage this data to create personalized customer experiences, boost sales, increase revenue, and deliver outstanding customer service. Retailers are even using smart sensors and Wi Fi to track the movement of customers, the most frequented aisle, for how long the customers linger in the aisle, among other things. Now, big data has changed the way of working in traditional brick and mortar retail stores. Over the years, retailers have collected vast amounts of data from local demographic surveys, POS scanners, RFID, customer loyalty cards, um, store inventory, and so on. They also gather social media data to understand what customers are saying about their brand, their services, and tweak their product design and marketing strategies accordingly. Seven is transportation. Big data analytics holds immense value for the transportation industry. In countries across the world, both private and government run transportation companies use big data technologies to optimize route planning, control traffic, manage road congestion, and improve services. Additionally, transportation services even use big data to revenue management, drive technological innovation, and enhance logistics, and of course, to gain the upper hand in the market. Okay, we have here the business challenges. So the focus is the customer and how to improve products and delivery of services to the customer. With today's environment, data tends to grow exponentially big, and to accomplish this, a lot of data needs to be discovered, processed, understood, and converted into meaningful and useful information. Okay, so how to use data to learn about customers? This is one of the business challenges that will prove to be most beneficial to a company once learned. Knowing as much as everything about one's customer can improve the way the company deals with customer. Focus on what the customer's needs are. Customize a happy customer experience and be able to find out what a customer wants to buy, the frequency on how many times a customer will buy when the customer buys something. It will also give the company information on what other things the customer may want to buy from the company. To solve this business challenge, these are the basic questions the company may want to know about the data they have about the customer. First, what data they have related to the customers. Data sets within the company in different format. This can be data in a database, which is structured data, data in flat files, data in documents like Word, weblogs, comments from the websites, and etc. Or other data repositories from within the company. Second, what data says about customers. A single piece of information about a customer might not mean anything for the company, but as pieces of information that are grouped together and related to each other, one will see that certain hidden information about the customer begin to be obvious. For example, um, will be just the customer's address may mean nothing, but if the customer's address is associated with the buying trends in the area where the customer is located, may unveil some selling opportunities for the customer. And we are just correlating two pieces of information. What if we can correlate more? Okay, the task to learn about data. So by now, we all know that the importance of data in a company. Now comes the task to process this data. First is identify the data. Where is the data? What type of data is there? And then locate data sources. You have to find the data that is needed. Load the data. You can load the data to the company's tools and then convert the data into usable format so that the company's tools can use it. And then you can analyze the data. Use the data into the company's analysis tools and refine the information. And lastly, convert data into usable knowledge. Use the data to make the appropriate action, such as concentrating on product that will be more significant to the customer. Improve on how products and services are delivered to the customer and take action based on the customer's feedback. Okay, now there are lots of places to look for data. They can be very challenging. For now, let's just consider three major areas in a company to look for data. First is warehouse data about purchase history. This is where traditional structured data is normally found. It can be record entry on a database system, it can be a relational database, a flat file system, or a combination of both. We also have the site browsing history of the customer. This is where the history of a customer's browsing in the company website is. And you can find here the web logs. This will tell the customer's interests about the company. And this can tell if the customer is looking for something that is not traditionally known to be a customer's interest. It may be a future interest of a customer or a current interest that is not yet known about the customer. Third is comments on websites. Comments on the company's website, such as blogs, forums, and other medium where the customer can freely express what they feel, experience, or what they think about the company. This is where the company will learn how happy or frustrated the customer is about the company, its products, and how they were dealt with by the company. Most of the time, it will give specific information about what a customer liked or disliked about a company with details of who, when, what it liked or dislikes. And lastly, customer surveys. It comes in several forms. It can be an entry in a website, a comment uploaded in the notes section of a relational database, a Word document stored as a flat file, or files of different formats as a result of a formal survey from external companies doing surveys for the company. Now we have here the business motivation. First, we have the launch customized advertising campaign. Customized and targeted advertising campaigns are most effective because it zeroes in to what a customer really wants. But to do this, a company needs to collate a lot of information about a customer and relate them to with each other. Second, gather data from different sources to get the complete picture. Getting the complete picture about the customer is very challenging because data can be in different locations, different formats and can be a part of structured collection of data, but some of its pieces are in an unstructured collection of data. Third, integrate data into meaningful records. Now, finding the data is one thing. Integrating them and make them meaningful is another thing. One great challenge is integrating structured data with unstructured data. How can you do a structured query language, for example, on data that is not structured? More so, combine structured and unstructured using a single query. Fourth, use the information to provide rich and usable results. How would one use if the information gathered to provide rich and usable results, such as good forecasting of trends, product enhancement, and new innovative products for the customers? We also have the technical challenges. Integrate from various sources, not compromise existing data structures and infrastructure, locate appropriate data, get data into a usable format, and analyze petabytes of data. Okay, so integrate from various sources, different data source platforms. Now, in a company, it will have a lot of sources of data, different hardware platforms, different database systems, different sources. It can be internal or external, like those coming from customers or suppliers. More often than that, there will be no control on what kind of data a company would have, and as a result, it will come from all forms of systems. It can also be possible that a company acquire other companies using completely different kinds of information systems. So these information may be in a form of different from each other. This is where we differentiate structured data sources, semi-structured data sources, and unstructured data sources. Okay, so we have the structured data sources, semi-structured, and unstructured. For the structured data, these are the data that is normally found in traditional databases. They can be queried and results are easily known because data source they are in has a structure. Therefore, a repeatable query can be done in most instances automated. Harvesting data from these systems is easy and has been mastered by most companies. We also have the semi-structured data, which are information that does not exist in traditional databases. So a traditional structured query language will not be able to get information from this. But since it has some form of structure, it is still possible to get data from here, and there will be additional challenges to do so, and more time it is needed to get those data. Third is unstructured data. These are data that does not exist in a database system or does not have structure at all. So these are the types of data that are written and stored in free form that the structured query language or other means cannot extract parts or certain part of its contents. Okay, so we have the technical challenges. Locate appropriate data. Locating the much needed appropriate data is knowing where they are and how they look like so that the appropriate tools can be effectively used. In the older days of the IT, getting data means creating SQL or the structured query language. that would dump the result into a report and the report analyzed. It was easy then because if the data is in the database, it can be queried. Any data not in the database during those times were considered not important and can be skipped. But as we learned along the way, there will be crucial data outside the database. So the IBM recently gathered data outside the database, like from websites, weblogs, the blogs, social media sites, and discovered that ladies' shoes heel size has direct relation to spending habits in a community. So this is something that will be hard to get as a conclusion only looking at structured databases. So the information gathered here came from structured databases, weblogs, the blogs, and comments from social media members. Okay, now that data was identified, collected, it needs to be placed into a usable format so it can be easily interpreted so proper action can be applied. Okay, so in the past, dealing with gigabytes of data was considered very astronomical. But today, with faster computer processors, faster network connections, and bigger storage capacities, data moving to and from its origin to its destination has also grown exponentially. A brief look at the amount of data being exchanged over the internet in a 10-minute period may reach in the petabyte level, about 1 million gigabytes or 1,000 terabytes to 1 petabyte. Petabyte is denoted by the symbol PB. So the fastest single computer will take long processing streams of data in petabytes. One will need a series of computers to process these kinds of information, running a file system that is enabled to allocate jobs to several computers. Okay, so we have here the IBM Big Data Platform. So we have the multi-channel customer sentiment and experience analysis, detect life-threatening conditions at hospitals in time to intervene, make risk decisions based on real-time transactions data, and identify criminals and threats from disparate video, audio, and data feeds, and also predict weather patterns to plan optimal wind turbine usage. Okay, so imagine if you could analyze the 12 bytes, terabytes of tweets being created each day to figure out what people are saying about your products. Figure out who the key influencers are within your target demographics. Can you imagine being able to mine this data to identify new market opportunities? Okay, so we have here hospitals could take the thousands of sensor readings collected every hour per patients in ICUs. The variety there is sensor readings, and the volume is the thousands. We also have one example here, make risk decisions such as whether or not someone qualifies for a mortgage in minutes by analyzing many sources of data, including real-time transactional data. So the many sources of data is example of volume, and real-time transactional data is an example of velocity. Lastly, law enforcement agencies could analyze audio and video feeds in real time without human intervention to identify suspicious activity. So the variety there is audio and video feeds, and the velocity is real time. Okay, now big data and analytics. So Watson is an IBM supercomputer that combines artificial intelligence or AI and sophisticated analytical software for optimal performance as a question answering machine. The supercomputer, named for IBM's founder Thomas J. Watson. The Watson supercomputer processes at a rate of 80 teraflops or trillion floating point operations per second. This is to replicate or surpass a high functioning human's ability to answer questions. Now, Watson's accesses 90 servers with a combined data store over 200 million pages of information, which it processes against 6 million logic rules. The system and its data are self-contained in a space that could accommodate 10 refrigerators. We have the Watson's components, key components included. We have the Apache Unstructured Information Management Architecture or the WIMA frameworks, infrastructure, and other elements required for the analysis of unstructured data. You also have the Apache's Hadoop, a free Java-based programming framework, and the SOSE Enterprise Linux Server 11, which is the fastest available Power 7 processor operating system. We also have the 2880 processor cores, the 15 terabytes of RAM, 500 gigabytes of pre-processed information in the IBM's Deep QA software, which is designed for information retrieval for incorporate natural language processing or the NLP and machine learning. Now, applications for Watson's underlying cognitive computing technology that are almost endless because the device can perform text mining and complex analytics on huge volumes of unstructured data. It can support a search engine or an expert system with capabilities far superior to any previously existing. Watson in healthcare. Now, the first commercial implementation of Watson came in 2013 when the Memorial Sloan Kettering Cancer Center began using the system to recommend treatment options for lung cancer patients. This is to ensure that they receive the right treatment while reducing costs. Healthcare was one of the first industries to which Watson technology was applied. So, since that time, providers such as the Cleveland Clinic Main Center for Cancer Medicine and WestMed Medical Group have also implemented Watson tools. However, not every implementation has gone smoothly. The MD Anderson Cancer Center in Houston launched a project in 2013 to build a decision support system powered by Watson technology. This is to help doctors determine the best treatment options. But after spending more than $62 million on the project over the course of 4 years, hospital administrators canceled the project, saying it had failed to meet its goals. In May 2018, for example, India's largest specialty healthcare system, Apollo, agreed to adopt Watson for oncology and Watson for genomics. The two IBM cognitive and computing platforms will help doctors to make decisions for personalized cancer care. The IBM's IBM's use of Watson to solve some of the biggest problems around patient care and using data driven insights to recommend treatment options would prove the value of Watson technologies. Now, healthcare remains a primary focal point for IBM as it tries to prove Watson technology, and the company continues to forge partnership with healthcare organizations. Okay, we also have the Watson Analytics. It is one of the primary implementations of Watson technology. It is a platform for exploring, visualizing, and presenting data that utilizes Watson's cognitive capabilities to automatically surface data driven insights and recommend ways of presenting the data. The platform is made up of an exploration component which allows users to upload their data, automatically recommends potentially correlated variables, and builds comparisons. A prediction tool that allows users to get answers to complex questions based on their data, and a reporting tool that supports dashboard and report development. Now, the platform is intended to make advanced analytics accessible to workers with limited technical knowledge. The cost of Watson Analytics depends on the version. There is a free version which includes the ability to upload spreadsheets, get visualizations, get insights, and build dashboards. Okay, so the IBM Watson's history. In early 2011, Watson, a supercomputer developed by IBM, competed in a popular question and answer show, which is the Jeopardy! 200 million pages of text is loaded in memory using big data technology, which is the IBM Big Insight. So, analytics is used to process the loaded data. This is an example of how big data was processed using the Big Insights or the Hadoop. Watson was successful to beat the two most popular players in that game. Watson was input approximately 200 million pages of text using Big Insights or the Hadoop to distribute the workload for loading this information into memory. Once the information was loaded, Watson would use other technologies for advanced search and analysis. So that's it for now. Thank you.